Hello everyone, so welcome back to my YouTube channel. Apologies for not uploading video for long time because I was not keeping well due to my personal health issues and I've not even practiced anything during that time. So let's just quickly start with today's question and we'll complete this series of 100 days lead code series first, and along with that I will be uploading concept based videos and some other videos that will help you grab placements and everything. So let's just quickly complete this question. So this is lead code 1415 and it states that there's a happy string which consists of only letters of the set A, B, C, and a happy string means that the string ith character should not be equal to its next character adjacent. And for example, it is given A, B, C, A, C, B, and this string a b c b a b and this, so it is a happy string, but a b a these are not, because since a and a are equal and they are adjacent. Similarly here, similarly if you see b and b are adjacent and they are equal, so we need to find a happy string which is kth happy string, and we are given an integer n also, which should be the length of that string. So let's just quickly look at the example. So we have n equals to 1 and k equals to 3. So one size string should be there and the like position of that string should be 3. A, B, C we can form from these letters only one size. So third string will be C. So we will return C. Similarly, if n is greater, let's just take this example. N is 3. So the length of the string should be 3 and we need to find the ninth string. So we can how many formations that we can make? It's 12. So it's ABA, ABC, ACA, and all are these happy strings, right? Because if you see, A and B are not equal, similarly B and C, so adjacent are not equal. And from this, if we find the ninth, it is this one, CAB, right? So ninth string is CAB. So we will return this answer. So let's just quickly move to the intuition building part and we will understand better there. So yeah, let's just start with the intuition building part. So we are given this n and we are given this k, right? And we have only these characters which can make a happy string. So now if you see that we are given n as 2, that means the length of a string should be 2 size, right? And with this 2 we have to find the third string, right? So let's just make tree diagram. So whenever you face a this problem and you need to like check for every possibility, that means that you have to find all possible happy strings, which means that it is somewhere kind of recursive solution, recursive problem, not solution. So it's kind of recursive problem where we need to find every possible happy string. So whenever in any question you find some possibility kind of thing, so you have to do some recursive thing, right? And since we have to find the third string, so we will check later how this recursive solution is, like this is also related to backtracking, right? So we will come to this later. Now let's just move to our problem. So we have these characters. Let's just try to late string. How many possibilities we can make? Let's just place a here. We have two size string, one is completed. Now what character we can place? Either B or C, because we cannot place A, that won't be a happy string. So let's just place B here, and another possibility will be AC, right? These all possibility we can make with A. Now if we start from B, we can take A here. Similarly we can take C here. Now similarly if we start from C, we can use A here, we can use B here. So how many possibilities we have? We have 6 possibilities and we have to find the third one. So which one is our third? If we start from, this is mentioned lexicographically, that means first we have to encounter all A ones, then all B ones, then all C ones. So this is our first, this is our second, this is our third, this is our fourth, fifth and sixth. So lexicographically third will be this one. So this is our answer, B. Now how we should approach this problem first. So if we manually try to find all possible solutions, that won't be a good. So now we will try to make some tree diagram, because in recursive solutions, how you will approach, like you find something, then you call again, then you find something, then call, and then you trace back and get your solution, final solution. Similarly, how we can make it? So let's just make a tree diagram that will help you make understand better. We have A, we have B, we have C. So since we have two len string, first we place A here, right? Now with this A, what you will do, you have to place something. So now you will call, now you have A, what you will place here, A, B. Now again you will call A with C here, right? Now you have find. So let's just take a length of 3, that will make the tree diagram better. So this is the ABC, N is 3, K is, let's just say, 4 only. So if you have to find 3 length, so let's just place A here. Now we will call again, we will find, we have A. Now we have to place another character that will be not similar to this, will be B. Similarly, A, C, right? Now again you call with this, and which character you can place here after AB? Again A, or you can place A, B or C. Nothing other than this you can form with AB. But let's just again do with AC. You have AC, but you can place here A, and you can place here A, C and B, right? Now if you see, you have three different strings. Similarly, if you place B here, now again you can make two possible solutions, and with these two, like you can make like two or more, like four solutions. So that will be, we can make separately here. Now B will use this B A and B C. Similarly, now you do B A and B A no, B yes. So we can place B here. Similarly, we can place C here. Now if you do B C A and B C B, we cannot place C here. Now this is A part is done, this is B part is done. Similarly, you can do with C. Same diagram, like CA will be here, C B will be here. Now again two possibilities for this, right? Since we have three characters for every part, you will have two possibility, right? If the length will be 4, how you can do? You can make two possibilities here, two here, two here, two here, right? Tree will go little longer in the height, right? So that's how you can make tree diagram, and this will make you understand better how the things are going. So now you have this problem understanding how we will solve it. Since we have discussed, we will use recursive approach, and there's a standard process for recursion, like what you will do. So what your standard process will be, let's just say you have these characters, these A B C, right? So what you will do, you will just take them in the string form. Let's just say string temp that will hold these characters A B C, right? Now what you will do, you will call some function solve and make an empty string, okay? That will gradually be built in this process, from here, then here, from here, then here. So we'll take that empty string. Along with that, you will, you need to store all these strings, right? This one, this one, this one. So then only you can find this kth. So what you will do, you will make some storage. So that will be vector of string, this will be result, and we will pass this result. Similarly, we will pass our, okay, we don't need k, but we can find, use our n size, right? And once this solve method is done, it will populate all the strings in this result. Now here you can return your result of k minus 1, right? So this is how your this solution method will be done. Now we will come to this solve method. So how we will do this solve? So this solve will have one string. Let's just say string s. It will be having one vector of string result, and it will be having a n that will help us in size. And now what will this method do, right? So we have we need to use this temp also, so we need to pass it here, right? So what you will do, you will go for each character of this temp. So we will update it here, one parameter that will be string temp, right? Now we will go for each character of temp, and what you will do, you will check if this is empty or not, and if it is not empty, then the character at the last position of the string is equal to the current character, then only you can do, right? So what you can make, if is dot length, so what you can do, we can directly check if your string length is not equals to 0, right? And your string's last character, that is string dot length minus 1, is equals to current character. If this is true, string length is not equal to 0, that means there is some character and 1 or greater than 1, and your last character is equals to your current character. That means you don't have to do anything, you just have to continue, because as we have encountered here, you cannot add, like in this case you cannot add a here. Similarly here you cannot add b. After a you are adding c directly, so we are just taking this is true, then you can just continue, right? If this is not true, that means you can directly add into your current character. So right, so string also has a method called pushback, so you can directly use, so you can add pushback. Similarly, since your part is done, you can call your solve method again with this string s and your result, your n, and your temp. This will gradually be called recursively. Now, when you are coming out, since you are adding explicitly into this, pushing this into this string, now you have to remove that character also. For like, take an example, you have a added, now you have added b. Now, if you are going back, you have to remove this b, right? Because a comes, you add it. Now part of b comes, this solve will make s into ab. Now when you are calling for another character, like let's say c for here, ac, you have to remove from this string, right? This string had to be made into a. So for that purpose, what you have to do, you have to pop back, right? We can check with the function name, but it is quite similar to the vector, so we will remove that character. Pop back will remove. Now your this for loop method is done, and this is how you can solve it. Now comes the condition at which this recursive solution will stop. If you won't add that condition, it will be called again and again, right? So now, because since you are adding and removing, so this will be called again and again. So how you can stop it? So you have to add some check here. Now if your current string length is equal to n, that's how many characters you need in your string, right? So if s dot length equals to your n, that means you have to stop here. Now your string is done, you just need to push it into vector. You can add directly, and after that you can just return from here. So this will, when you reach this length, you will directly return, and you will come back here, then you will remove your character, you will stop here. Now this part is done, and now we will discuss the time complexity and some minor improvement here only. So the time complexity, if you see, let's just understand how we'll calculate it and space complexity also. So time complexity will be, so this will be your method that will be calling this solve and returning your result. So one check that if you will be encountering, since you are returning this result and the range of k and n are almost like in the range of k is like 100 and n is 10. So sometimes, like let's just say it can be one of the test case, if you encounter n can be 2 and k can be 100, is it possible to get the 100th happy string with just only 2 characters? If you try making test cases for that, how you can make AB, AC, BC, BA, and CA and CB. So only 6, but you have to return 100. In that case, it is mentioned in the question statement that you have to return empty string. So what you can do, you can simply, when you are calling this method, after that you can add a check here. If result dot size is less than k, that means you cannot find the kth string. You can simply return empty string, right? Else you can just return the kth string from this result. Now the time complexity part, if you see, you're calling this recursive solution, and what is recursive solution doing? This will be called for, this for loop will be called for 3 loops, right? 3 characters. So 3, and since what you are doing, you are adding this character, removing back, that will be O of 1, but you are calling this again and again. And how many times this is called? If you see, let's just say you have 4 size or 5 size. For this position, how many characters you are having? You can have any 3 characters, right? It can be A, it can be B, it can be C. But for all these, how many characters you can have? 2, because if you use A, then B can come here or C can come here. Similarly, if you use B, A can come here, use B, or C can come here, right? For almost all positions now, only 2 possibilities are, if you use B, then A or C can come here. If you use C, then how many possible solutions? B or C, right? Now, so for all these two can come. And if this length is n, then how many possible ways? It will be 3 here. And for this part, you see this length is n minus 1. Since this is 1, so 3 multiplied by, since only 2 characters we can place, so 2 keep power n minus 1. So the time complexity, if you see how many we are having, that will be 3 into 2 keep power n minus 1, right? And one thing, if you see this operation, this is also being called for every possibility. When you are like getting into the length of n, you are simply adding into your vector. Since this is a string of length n, you are adding into this vector, that will be operation of n, not big of 1, because the length of string is n here. This whole will be called n times, and this is your time complexity, right? That's how you calculate your time complexity in case of recursion. Now we come to space complexity part. If you see, we are mostly using this space result, and how many strings it will store, right? It will store all the possibilities. So that will be, or all possibilities are 2 to the power n. We have these number of possible strings, and all strings have a length of n. This is your space complexity. N is the length of the string, and this is the number of possibilities. So this is how you can solve this problem. So now we will move to the coding part, and one thing that we can improve on this, that you can try on your own, and if you like face any problem, you can add in the comment. I will make a part of that video in the next video. Like, one improvisation you can make is optimizing the space complexity. What you can do, instead of taking this whole vector, you can just simply take one string that will be your resultant string, and whenever you count comes to kth, you can have your resultant string as your answer, and you can return there, right? So I will give that opportunity to every one of you to make that solution on your own. If you face any difficulty, you can add in the comments and I will make a small video on that too. So let's just quickly move to the coding part. Okay, so we can quickly start with the coding solution. So let's just first, what we have to need, we need to have a temporary string which have all these characters A, B and C, so that we can iterate over it, right? Now what you will do, you will require a vector that will store all the solutions, so that will be our result, right? Now what you will do, you will call your solve function. First you need a empty string so you can directly pass it. Now you will require your n, right? Now one thing, 10, that will be this string. We can make it more meaningful letters. And now your result. Once you come back from here, what you will need to do, you need to check if your result dot size is less than k. Now you can simply return your this, right? Else you need to return result dot k minus 1. One thing that we have missed during rendition building part, this lexicographical, right? Since we are gradually building from A, B, C, so that won't be like cause or any problem. But in case this lexicographical is specifically asked in any of the question, you have to do some kind of sorting to get your answer, because sorting can give you lexicographically sorted strings, right? And now we will write our solve method. So the solve method will have a string s, that will be your this string that you will be building, your n, similarly your string of letters, and one thing, that your vector of string. I am adding ampersand sign here because this result will be used like in all the recursive calls, and we need to store all the strings in this resultant. That's why I'm adding ampersand sign here, so that the memory is not removed during all the recursive calls. So first you have to call your for loop for characters ch for every letter. So letters, right? You can make it meaningful letter. Now what you have to check, you can directly check if your string dot length, as we have discussed, it's not equal to 0, there is some character, and your last character, that is string dot length minus 1, last character is not is equal to your current character. That means you have to not do anything and you can continue. Now if this is not happening, that means you can directly add in your string. So we can use a pushback method for adding the current character. Now we will call our solve function with the string in letters and a result, right? Now since you are building your solution while adding A, B and C, but when you are coming back, that is called backtracking, you have to remove this last character, because then only you can build your answer. If you want to build like you have A, B, now you have to make it A, C. That means you have to first remove B while coming back, and then building C. So this is called backtracking. When you are coming back, we have to remove this character last, so that is pop back. Now most of the part is done here. Now since this is a recursive call, from here you have to stop it at some point. That's how you comes the base case. So when it comes, when your string dot length equals to n, then you have reached your solution, right? What you have to do, you have to add your current string into the result. So result dot pushback your s, and now since you don't have to build the greater size, you can just stop here and you can return, right? So let's just try running it. Okay, there's some, okay, we have used letter here, so we have to update here, we have to update here, right? Yeah, it is working fine. Let's just do the submit part. Yeah, so we have submitted this successfully. So thanks everyone for watching. In case you do like this video, please do hit the like button and hit the subscribe button to turn on the notifications. And in case you want to have all the videos of such content, you can like subscribe to my channel and turn on the notifications. And I will be making concept based videos in the coming days based on searching, sorting algorithms and other tech related videos. So stay tuned for that. Stay connected. Thanks everyone.